Violex Ming.
Hi, I'm Bernardo Rodriguez.
And I'm McDonald.
And our project is on machine learning and predicting UFC fight outcomes. So this is just a brief overview of what we plan to go over in our presentation. And just an overview of the project. So many UFC fans participate in betting competitions, and the goal here is to predict which of the players are going to win and which are going to lose. And this led us to research how can we use data to help predict for these odds.
For the data collection, we decided to get our UFC data from Kaggle. This is very unprocessed data in which each row is an example of each fight for the last 20 years, but we only decided to use fights data from 2017 to now. For the YouTube API data, we decided to search up the statistics of the likes, dislikes, comments, and views statistics for each of the players from 2017 to present. And then we all added that to our data set. Some adjustments to the data set that we made was we added the variable last match, which created a categorical variable on when was the last time a fighter has fought. In addition, we filled in missing YouTube data and missing variables by either dropping them or changing them to 0. And in addition, we decided to take things replace things like wins, draws, and losses into a win ratio so that we can better compare fighters who are both younger or maybe more experienced to give a more fair comparison.
So now we have our feature engineering, or further feature engineering, I should say. So we use 4 different methods. First, we would encode all categorical data. The second method, encode all categorical data except for ref rate and location. The third is just manual variable selection using stats taken off of the UFC website. And the fourth is encode all categorical data except for ref rate and location. And the fourth method was actually chosen because, oh, I'm sorry, I skipped something. The fourth method is encode all categorical data except for ref rate and location, and then remove duplicates, chi-square reduction, and train test split. So remove duplicates is getting rid of columns that contain the same data, not columns that are identical per se, but columns that indicate when the fighter last fought is never, or the fighter is a new fighter. Chi-square reduction reduces columns based on their chi-square, which tests the relationship or the chance of a relationship between two categorical variables. Yeah. And then this is the final the testing overview of our feature engineering. I use a simple logistic regression model, and then we fit and trained on each method's training data, and then we validated on each method's testing data. And from there, we chose the final method of feature engineering. We went with method 4 because it had the highest accuracy with the lowest amount of variables because we use chi-square reduction.
So we trained 4 models on this data and the features that were selected for model 4. We trained a logistic regression, decision tree classification, gradient boosting classifier, and a random forest classifier, for which we also used grid search CV to select for the optimal hyperparameters, and then ended up actually selecting the random forest classifier because of our ability to tune the hyperparameters going forward. Even though it didn't actually achieve the most accuracy, as you can see here, logistic regression was actually the winner by a little bit, but the ability to tune the hyperparameters gave us more freedom going forward, and just the option to actually maybe even achieve a higher accuracy going forward if we were to continue on with the project. And this is just some snippet that we used for testing code for the final model. Our findings were that our final model, which testing on the actual testing data, achieved a 59, almost 60% accuracy, which was higher than the baseline, like just predicting a random winner, and even higher than also just predicting the winner from a certain corner to win, which is the red corner.
In conclusion, we created a model that can be practically utilized by bettors to inform bets that they want to make. Again, this will be all through personal choice. So we would only recommend maybe modest bets. And any possible changes that could be included, we can include some VIF reduction. We can drop rows with empty cells from the very beginning. And we can also extend the data timeline. And this could affect the results of our model in the future.